Hello, welcome to another interesting mathematics class. My name is AK Omoji, your mathematics friend and tutor. Today we shall be continuing our discussion on quadratic equations, and we shall be talking specifically about the completing the square method. By the end of this class, you should be able to 1. Prove the completing the square method, and also you should be able to apply the completing the square method. In completing the square method, we actually play around squares. And as you can see on the board, we have the Rubik's Cube and a 5x5 square puzzle. Now, in our Rubik's Cube, what we are trying to achieve is to ensure that each face of the cube has just one color. That is to say, we are trying to complete each face with just one color. So I can say we are trying to complete the square in each face with just a color. For instance, we might just want red here. So all will be red, red, red all through these boxes. In the 5x5 square puzzle, we'd also repeat the same thing. Let's assume we want to have the yellow all through here, the red here, the blue, the green, and so on. That is just what the completing the square method looks like. Now, what does the completing the square method actually mean? The completing the square method is a method used to solve quadratic equations. This method changes the form of the equation so that the left-hand side is a perfect square. For instance, you can see that x squared plus bx over a is equal to c over a. X squared plus bx over a is the left-hand side, whereas c over a is the right-hand side. The completing the square method is like solving a square puzzle, like I said earlier, where we have to find a missing part of a square. Completing the square looks like an expansion process. For instance, let's take a look at this diagram, and let's assume that this diagram is a square for now. And let's say that the sides of this box are x plus 1. This means that if it is a square, the length and the width should be equal. We would have x plus 1 and x plus 1 on both sides. Well, how did I come about the x plus 1? If you look at the diagram, you see that there is an x in the yellow part, x raised to power 2, and the two green parts have 1 times x, which are shown there as just 1x. And then there's a red part, which we do not know, this part. And that's what we are expected to find. If we say it's a square, that means we agree that the length and the width are equal. That is a basic trigonometric rule. If we agree with that, we can then say that the area is x plus 1 both squared, because it is length times breadth or width. And so if we expand this x plus 1 squared, we would have x plus 1 times x plus 1. Please take note, if you have a squared, it's just the same thing as saying a times a. That's exactly what we did here. So now we have x plus 1 times x plus 1. When we expand that by multiplication, we would say that x times x will be x squared. Also, x times 1 will be 1x. 1 times x would also be 1x. And then finally, 1 times 1 will give us 1 squared. Of course, 1 squared you know is 1, but we're going to leave it for now as just 1 squared. Next, let us collect like terms. 1x plus 1x are alike. When we add them, we would have 2x. So we now have x squared plus 2x plus 1 squared. Remember I said 1 squared is same thing as 1, but for now, we'll just leave it as 1 squared. So finally, we can say that x plus 1 both squared is equal to x squared plus 2x plus 1 squared. You can say as well that x plus 1 squared is a complete square of x squared plus 2x plus 1 squared. This leaves us with the finding that the red part is simply 1 square. Before we apply the completing the square method to solve any problem, there are some things we need to know. And some of them I will show you now so that you look out for them whenever you want to apply the completing the square method to solve any quadratic equation. So let's look at some of them. To be able to apply the completing the square method, you should know that 1. The coefficient of x squared is any value in front of x squared. 2. The coefficient of x is any value in front of x. 3. The coefficient of x squared or x can either be positive or negative. And then 4. The constant is a known value and it can also be either positive or negative. Take a look at these equations by your right hand side. You will see that we have 2x squared plus 3x plus 5 is equal to 0. You could see that the coefficient of x squared, which is a value in front of x squared, is 2, right? So it's a positive 2. I indicated that by putting the plus in front of 2 to show you that it's positive in this case. While also the coefficient of x is 3 because that's a value in front of x. And in this case, it's also positive, indicated as plus 3. And the constant here is 5. Also, I indicated that as plus 5 to show that it's positive here. In the next one below, you can see all the coefficients and constant labeled. And also note that in this case, the coefficients are all negative and the constant is as well negative. So now let's go on and prove the completing the square method. Let's assume that we have a standard quadratic equation giving us ax squared plus bx plus c equal to 0. And we are required to solve it using completing the square method. Notice that I call this standard quadratic equation. The reason for that is not all quadratic equations are in their standard form. A standard quadratic equation has the x squared term, the x term, and the constant all in the left hand side, and they are all equated to 0 on the right hand side. In the equation we have a is a coefficient of x squared, b is a coefficient of x, and c is a constant. To start our proof, the step 1 states that we should divide through by the coefficient of x squared, which in our case is a. Our original equation is ax squared plus bx plus c and is equal to 0. And the first step says we should divide through by a. That means we should divide everything by a. When we do that, the a in the first term would cancel out. So we'll now be left with x squared plus bx over a plus c over a is equal to 0. And we'll call this equation 1. Moving on to step 2, we now have to move the constant, which is c over a, to the right hand side of the equation. Remember, our equation 1 was x squared plus bx over a plus c over a, and that's equal to 0. To move c over a to the right hand side, what we need to do is to subtract c over a from both sides. Doing that will eliminate c over a from the left hand side. So let's do that. We'll now have x squared plus bx over a plus c over a minus c over a is equal to 0 minus c over a, right? The c over a here will be eliminated by this c over a because any value subtracting itself becomes 0. When we do that, we now have x squared plus bx over a is equal to minus c over a. Let's call this equation 2. Now our step 3 says we should divide the coefficient of x, which is b over a, by 2, and then square the results and add to both sides. This actually has like 3 steps in it, so we'll take them gradually. First, let's recall that our last equation, which is equation 2, was x squared plus bx over a, and that's equal to minus c over a. So we are asked now to look for half of b over a. Please take note, if you have an expression like this, a over b divided by c over d, from our basic algebra, this can be written as A over B times D over C, right? So we'll apply that now. We are saying B over A divided by 2 over 1. Of course, 2 over 1 is still the same thing as 2. So if we divide by 2 over 1, it's still the same thing as saying divide by 2. Applying what I just did earlier, we now have this to be equal to B over A times 1 over 2. That leaves us with B over 2A, right? Next, we are asked to do what? Square what we just got. So to square it means we just have B over 2A squared. That's the next thing we have to do. And then finally, we are asked to add this result to both sides. Both sides means the left-hand side and the right-hand side. So let's do that. So by adding B over 2A squared to both sides, we now have x squared plus bx over A plus B over 2A squared, and this is equal to minus C over A plus B over 2A all squared. Let's call this equation 3. The next step now is to complete the square on the left hand side. Please remember our last equation was x squared plus bx over A plus B over 2A all squared, and that is equal to minus C over A plus B over 2A all squared. Now, what we mean by completing the square on the left-hand side is simply to take these squared terms together. And how do I do that? I'll simply say x plus B over 2A all squared is now equal to minus C over A plus B over 2A all squared. Now you might ask, how did we get the left-hand side? Well, if you look at that, it's simply an expansion. Look at this. Do you know that x plus B over 2A all squared is the same thing as what we had earlier? X squared plus bx over A plus B over 2A all squared by expansion of this left-hand side. And that's why it's true. So what we've just done is to complete the square on the left-hand side. Now, let us call this equation equation 4. Now, in step 5, we have to take the square root of both sides and then evaluate. Let's take the square root of both sides. Our last equation, we stopped at x plus B over 2A all squared, right? And we said it's equal to minus C over A plus B over 2A all squared, right? Taking the square root of both sides simply means we should take the square root of the left-hand side and then the square root of the right-hand side. If we do that, the square root on the left-hand side, which is this, will be cancelled by the square on that same left-hand side. Please note that square root of A squared is equal to A. This is coming from your simple indices. So when we do that, we now have x plus B over 2A is equal to square root of minus C over A plus B over 2A all squared. You might ask why the square root on the right-hand side was not cancelled. Please note, this term does not have a square. So that's why it didn't work on the right-hand side. Okay, let's call this last equation 5. Next is our sixth step, which is to make x subject. Remember, making x subject simply means making x subject of the formula. So how do we do that? Our last equation, we stopped at x plus b over 2a, and we said it's equal to square root of minus c over a plus b over 2a all squared, right? That was where we stopped. So to make x subject, first thing we need to do is subtract b over 2a from both sides. So subtract b over 2a from both sides. X plus b over 2a minus b over 2a is equal to minus b over 2a plus or minus square root of minus c over a plus b over 2a all squared. So the b over 2a cancels b over 2a. They are all out because a number, when it subtracts itself, will give you 0. So we are now left with x is equal to minus b over 2a plus or minus square root of minus c over a plus b over 2a all squared. Next is for us to solve this equation. The last equation we had was x equal to minus b over 2a plus or minus square root of minus c over a plus b over 2a all squared. Like I said, this square root extends to here. That was our last equation. So if we want to really work on this equation, what we need to do first of all is to open up the left hand side. But before we do that, why do we have this plus or minus here? The reason for that is because we do not really know whether this square root came from a positive or a negative number. For instance, 2 squared is equal to 4, right? Also, minus 2 squared would also give us 4. That is to say that both 2 and minus 2 will both have their square to be 4. Okay, that handles this plus or minus sign. Now, let us expand this value in the bracket here. Note also that b over 2a all squared is the same thing as just from your indices b squared over 2 squared times a squared, right? That means we can write this as b squared over 4a squared. So we now have x equal to minus b over 2a plus or minus square root of minus c over a plus b squared over 4a squared. Now, let's take the LCM of these values in here. What's the LCM of the denominators, which are a and 4a squared? It is 4a squared. Now, to continue, we can now say that both of them have an LCM of 4a squared, right? Solving true, we now say that 4a squared divided by a will give us 4a. Multiply that with c, you would have minus 4ac plus, again, 4a squared divided by 4a squared will give us what? 1. Now we have b squared times 1, which is the same thing as b squared. So this is where we are now. X is equal to minus b over 2a plus or minus square root of what we just found now. Remember from our last equation, we have been able to establish that x is equal to minus b over 2a plus or minus square root of minus c over a plus b squared over 4a squared. And then we solve through and discover that x is equal to minus b over 2a plus or minus square root of minus 4ac plus b squared all over 4a squared. Now we are going to take the square root of the numerator and the denominator. And you know from your sort that if you have square root of a over b is the same thing as saying square root of a over square root of b, right? So let's apply that here. We will now have x is equal to minus b over 2a plus or minus square root of numerator, which is minus 4ac plus b squared over square root of the denominator, which is 4a squared. Remember from your sort that if we have square root of 4a squared, it's the same thing as saying square root of 4 times square root of a squared. So going by this, we can say that square root of 4, of course, is 2, right? And then square root of a squared is the same thing as a. That leaves us with 2 times a, which you can just write as 2a, right? Okay, so we now take this and replace the denominator on the right hand side. So we now have x is equal to minus b over 2a plus or minus square root of minus 4ac plus b squared all over 2a. Now looking at the two denominators we have, which is 2a and 2a, they are the same. So we can take their LCM to be equal to 2a. And when we do that, we will now have x is equal to minus b plus or minus square root of minus 4ac plus b squared all over 2a. Okay, we are almost done. Now let's rearrange what is inside the square root. Okay, so now by rearranging what is in the square root, we can now have x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. Let's call this equation 6. This equation 6 is also referred to as the almighty formula. For now, we've gotten to the end of the proof, and you've also been able to derive the almighty formula. Having gone through that proof, now let's look at some examples. Example 1. Solve the equation 5x squared minus 40x minus 20 is equal to 0 using the completing the square method. Solution. Recall our step 1 is to divide through by coefficient of x squared, which in this case is 5. If we divide this equation by 5, divide through this equation by 5, you would have 5x squared divided by 5 minus 40x divided by 5 minus 20 divided by 5 and is equal to 0. Note that 5 can be divided by 5 will give us 1, so that will mean x squared. Also, 40 can be divided by 5 as well, 20 can be divided by 5, but we'll leave it for now. Step 2. Move the constant, which is minus 20 over 5 to the right hand side. When we do that, we would have this. That's x squared minus 40x divided by 5 is equal to 20 divided by 5. Recall that when a negative sign moves across equality sign, it becomes positive. And that's why minus 20 divided by 5 has become 20 divided by 5. Because 40 and 20 are divisible by 5, this can be simplified to 40 divided by 5 will now become 8x, and then 20 divided by 5 would be 4. So our equation becomes x squared minus 8x is equal to 4. Let's call that equation 2. Now our step 3 is to divide the coefficient of x, which in this case is now minus 8 by 2. When we do that, we have minus 8 divided by 2, and then next is to square it, which will now be minus 8 divided by 2 all squared, and then we add that to both sides. Now that is our equation 3. Step 4, complete the square on the left hand side. Remember, this means we should collect these terms that have powers of 2, which is squared. Now when we collect the square terms on the left hand side, we have x minus 8 over 2 all squared, and that should be equal to 4 plus minus 8 over 2 squared. Step 5, take the square root of both sides and evaluate. So this will give us square root of x minus 4 squared, and that's equal to square root of 4 plus minus 4 squared. The square root on the left hand side will be cancelled by the square. So we'll now be left with x minus 4 is equal to square root of 4 plus minus 4 squared. Now our step 6 is to make x subject. If we solve what is in the brackets, we would have minus 4 squared will be 16, right? So we now have x is equal to 4 plus or minus 4. We now have x is equal to 4 plus or minus square root of 4 plus 16. Solving through, we added 4 plus 16, and we now have square root of 20. Now, if we find the square root of 20, we have 4.47 in 2 decimal places. And then now we have x is equal to 4 plus or minus 4.47. We now have x1 is equal to 4 plus 4.47, which is equal to 8.47. Or we say x2 is equal to 4 minus 4.47, which is equal to minus 0.47. Note, the reason why we have to do this in 2 places is because of the plus and minus sign from the formula. So we first of all took the plus, and then later on we took the minus. We now have the solution for 5x squared minus 40x minus 20 equal to 0 to now be x equal to 8.47 or x equal to minus 0.47. Okay, let's try one more example. Example 2. Solve the equation 2x squared minus 3x minus 9 equal to 0 by completing the square method. Solution. Now, let's follow the steps we had earlier. Remember, the first step is to do what? Divide through by the coefficient of x squared, which in this case is 2. By dividing through, we would have this equation, which we call equation 1. 2 will divide 2, and we'll be left with only x squared there. However, minus 3 cannot be divided by 2. Also, minus 9 cannot be divided by 2, so we leave them like that. Next, we move the constant term to the right-hand side. So we say add 9 over 2 to both sides. If we do that, minus 9 over 2 from the left-hand side will be eliminated. And now we have 2x squared over 2 minus 3x over 2 to be equal to 9 over 2. That gives us equation 2. Recall I said 2 is divisible by 2. So we can now move on and say, now let's look for the coefficient of x. We'll get the half of it, square it, and then add it to both sides. When we do that, we'll have half of it to be minus 3 over 4. And when we square it, we'll get this expression. We'll add that expression to both sides, which is this and this. That will give us our equation 3. Now, let's complete the square on the left-hand side. When we do that, we'll have this, right? And then the right-hand side remains like this. Next is to take the square root of both sides. By taking the square root of both sides, we'll end up with equation 5. Recall, these 2 cancels out the square root. Next, x is equal to 3 over 4 plus or minus square root of 9 over 2 plus 9 over 16. Please note, what we did was just to move minus 3 over 4 to the right-hand side. Next, we have 3 over 4 plus or minus square root of 72 plus 9 over 16. So how did we get that? All we did was to look for the LCM of 2 and 16. And then what we do that, the LCM is 16. And then 16 divided by 2 is 8. 8 times 9 is 72. And then next, 16 divided by 16 is 1. Then 1 times 9 is 9. This now is equal to 3 over 4 plus or minus 81 divided by 16. Of course, you know 72 plus 9 is 81, right? Okay, we look for the square root of the numerator and the denominator, which we did earlier. From SOD, we have 81 over square root of 16. And that will end up giving us 9 over 4, which is what we have here. This now means that x is equal to 3 over 4 plus or minus 9 over 4. We know that their LCM is 4. And so 4 divided by 4 will still remain 1, right? So we have 3 plus 9 divided by 4, which is equal to 12 over 4. And that will end up giving us x1 to be 3. Next, we can say x2 is equal to 3 minus 9 divided by 4. And that's also equal to minus 6 divided by 4. And that leaves us with x2 equal to minus 3 over 2. We now have the solutions for 2x squared minus 3x minus 9 equal to 0 as x equal to minus 1.5 or x equal to 3. Having solved through all those examples, now let's have a recap of everything we've done so far. We learned that in completing the square method, we solve a quadratic equation by applying some steps. These steps are: 1. Divide through by the coefficient of x squared, which in our case was a. Step 2. Move the constant, which is c over a, to the right-hand side. 3. Add square of half of coefficient of x, which is b over a, to left-hand side and right-hand side. 4. Complete the square on the left-hand side. And then finally, solve for x by simply making x subject. Now I want to test your knowledge on what we've done so far. So let's go through these simple exercises. Question 1. What are the values of a, b, and c respectively in the quadratic equation minus x minus 2x squared minus 2 equal to 5? The answer is D. Question 2. By applying the completing the square method, we obtain the correct roots of the equation 3x squared minus 11x plus 6 as the answer is C. X is equal to 3 and x is equal to 2 divided by 3. Thank you for your time. I believe you can now prove and apply the completing the square method to solve quadratic equations. Till we meet in another class. Bye-bye.